In today's video, we're going to be learning on how to solve the coefficient of friction of an object on a sloped ramp. Let's have a look at the problem here. A person pushes a 53-kilogram crate at a constant velocity up a ramp onto a truck. The ramp makes an angle of 22 degrees with the horizontal. Now, when dealing with physics questions like this, it's always best to draw a diagram to be able to visualize the situation. And that is what part A recommends. It says draw an FBD, or a free body diagram. Let's go ahead and do that. FBD. I'm going to be drawing the FBD in reference to the ramp because it makes it easier to visualize the angles. So first I'm going to draw the ground, and then I'm going to draw the ramp at 22 degrees. Now that might not be exactly 22 degrees, but this is good enough to be able to visualize the situation. So then I'm going to draw the star of the show, which is the crate. And then afterwards, I'm going to be thinking of the different forces that are applied on the crate. So the first force I can think of is the force of gravity, and that would be straight down like so. The other force would be the normal force, which is the force exerted by the surface onto the subject, which is the crate here. And that's going to be perpendicular to the surface. So that is our normal force. The other force would be the force applied, because the question says that a person pushes the object up the ramp. So that's our force applied. And in this particular question, it mentions the coefficient of friction, which means that friction is involved, and friction is always in the direction that opposes motion. And since the crate is moving up the ramp, this means that the force of friction is pointing down the ramp. Like so. So this is force of friction. Specifically, this is kinetic friction because the object is moving. So I'm going to add a subscript K to indicate that it is friction that is kinetic. Now, when dealing with vectors that are pointing in all sorts of different directions like this indicates that we would need to break them down into their subsequent components, that is x and y. You might be wondering which direction is x and which direction is y. We can use the standard vertical as y and the standard horizontal as x. However, if you do so like this will actually make the question a little bit more complicated, because this requires a lot more forces to be broken down into their subsequent components. So when dealing with sloped surfaces, like so, it is actually easier to align your x-axis with the surface of the ramp itself. So let's make the x-axis align with the surface of the ramp. So it's going to be parallel to the ramp like this. So that is our positive x-axis. So it's going to be parallel to the ramp, and then the y-axis is going to be perpendicular to that, like so. If we choose this frame of reference, or this axis, this makes it a lot easier, because the only force that would need to be broken down is the force of gravity, because the rest of the forces align with those axes. So you can see that the normal force aligns with the y-axis, and the force applied and the force of friction aligns with the x-axis. So let's go ahead and break down the force of gravity into their x and y components. So I'm going to draw it in dotted lines here. So in this case, that is going to be our FGY to indicate that that's the y component. And then this one here, this is the one in blue, is going to be our FGX for the x component. Now, let's take a look at the angle that over here. What is this angle theta? Okay, what is this? Let me go ahead and break down the problem further, specifically the angles. So let's first start drawing the ramp. Again, this is 22 degrees. So 22 degrees. Okay, and then I'm going to draw a line straight down to represent the FG that we had. So that is our FG, right? And then I'm going to draw our FGY right here. So this is our FGY, which is perpendicular to the ramp surface. So that is our FGY. And then I'm going to draw the FGX. So that is our FGX, right? Now let's break it down here. So again, this one here, the triangle on the left here, this is a right angle triangle. So specifically that angle there is 90 degrees. So what is this angle here? What is this one? Let's think about that. Okay, so this is a triangle, which means that all the angles add up to 180 degrees. So this means that this would be the remaining angle from 180 minus 22 degrees minus 90 degrees. And that leaves us, if we do quick math here, that's going to be 68 degrees, right? Okay, so we have that angle there. Then how does that help us find theta here, the green one? How does that help us? Well, let's have a look here. Now, if we see the angle between the white line, the surface of the ramp here, and the red line here, that makes 90 degrees, right? Because FGY is going to be perpendicular to the surface of the ramp. So that means that theta, so again, just to make it even clearer here, so this angle here, so I'm going to draw that in white. So this angle here, this adds up to 90 degrees as well, right? So that means theta is going to be equal to 90 degrees minus 68 degrees, which gives us 22 degrees. Now, if you notice, this angle here of the ramp and this angle here matches. So in most cases where you have this particular setup, these two angles will match the 22, will match each other. So if this is 30 degrees, that angle there will also be 30 degrees as well. Okay, so now we have the setup or the situation here. Let's go ahead and look at part B. So part B says, if your applied force is 373 newtons, what is the coefficient of friction between the crate and the ramp? Okay, let's have a look at that. Okay, so let's actually redraw the setup to the part we want here. Okay, so let's take a look at this. Okay, so we have, so our kind of focus is to actually just break down this force of gravity, because the other forces do not need breaking down. Let's have a close-up. Let's have a close-up of the force of gravity broken into components. Broken into components. So we have our Fg, like so, straight down like that. And then we would have our Fg, this is our Fgy. And this is now our FGX. Now, when dealing with these sorts of questions, all you have to do is just take a look at the components or the force components in the X direction and in the Y direction separately, and essentially just balance the forces using F equals ma. Okay, so let's have a look at the Y components first. So let's use Newton's law here, Newton's second law. So we do the force is equal to ma. However, specifically, we're going to be looking at the Y component first, like so. Ay is equal to 0 because crate stays at constant velocity in Y direction, because it's not moving at all. So that would mean that if Ay is 0, right? If this is 0, this would mean that our sum of the forces in the Y direction is equal to 0. Correct? And then let's actually take a look at the forces from the FBD. So let's actually draw that here. So we do force, the summation of the force in the Y direction is going to be our, as you can see, Fn and Fgy, because we're using this frame of reference here, right? So Fn, let's take that as the positive because that is what we said. So it's going to be Fn minus Fgy is equal to 0. And then if we then rearrange the equation, this is going to mean that Fn is equal to Fgy, and then we can then break this down further. So this angle here, this angle right here, the green one, that's theta, and that is equal to 22 degrees. 22 degrees. So Fgy, if we see here, our Fgy is going to be Fg, it's going to be Fg cos theta, right? Cos theta, right? And then our Fgx here, Fgx is going to be Fg sine theta. If you don't remember, it's going to be like so. So cos is adjacent over hypotenuse, right? So if we do that, cosine theta is going to be, so the adjacent of theta there, or adjacent is Fgy, and our hypotenuse here is Fg. So you can see that if we rearrange the equation, we would get Fg is going to equal to, what I meant is Fgy is going to equal Fg cos theta, right? Same goes for the Fgx, right? So that would be, so sine theta is going to be opposite over hypotenuse. So sine theta is then equal to Fgx over the hypotenuse, which is Fg. So our Fgx is equal to Fg sine theta. Okay? So then let's go back. So Fgy here is then equal to mg, right? Because force of gravity is mg. So that is that part, mg, right? And the, I'm sorry here. So force of gravity is mg. But then we're taking a look at the y component. So that is cos of theta, which is 22 degrees. So essentially Fn is equal to mg cos 22 degrees. And that's as far as we can go with the y component. So now let's take a look at the x component separately. So I'm going to draw a line here, and we'll take a look at the x component. We're going to follow the exact same method here, okay? So here, the summation of the forces in the x direction is equal to max, okay? And similarly, ax is equal to 0 because the crate is pushed at a constant velocity. So constant velocity means that the acceleration is 0. So if we take a look at the question here, it specifically mentions the crate is pushed at a constant velocity. Okay, so constant velocity, because crate is pushed at constant velocity. Constant velocity means acceleration is 0. So that means that this also adds up to 0 as well. So then let's take a look at the actual forces itself. So let's have a look here in the x directions. There's a lot more forces involved here, but a lot of them lines up. So we have, if we take a look at the diagram, we would have Fa, we would have the force of friction, and then we would have the force of gravity in the x direction. So that's the thing in blue, okay? Let's have a look at that. So we have selected up the ramp as the positive x. So let's go ahead and keep that in mind as well, okay? So that is going to be Fa, right? The force of applied, and then minus our Fgx, right? That's the force of gravity in x, and then the force of friction, kinetic, right? And that's all going to equal to 0. So let's do some algebra here and rearrange. So the applied force is going to be Fgx plus the force of friction kinetic. Now, let us break it down further. So our force applied, they mentioned in the question, that is 373 newtons, right? And our FGX, right, as we have solved before, that is equal to our FG times sine theta. So Fg, the force of gravity, is going to be mg sine theta, which is 22 degrees. And that's going to be added with our force of friction. Now, force of friction is defined as the coefficient of friction, and in this case, it's the kinetic one, multiplied by the force of normal, or the normal force. So this is the definition. This is the definition of Fk, right? So it'd be the same for the static friction as well. But the static friction, the coefficient is going to be the coefficient of static friction instead. But the formula essentially remains the same. So now we have this equation, and notice how Fn here we have already solved. So Fn partially, right? So Fn we can find from our y component earlier. So let's go ahead and sub that in. So we're gonna sub in Fn, right? So I'm gonna sub in Fn. Let's see what we get here. So it's gonna be 373 mg. So we're gonna leave mg as mg for now. And then sine 22 degrees. And then we're gonna do mu k times Fn. Fn is going to be mg cos 22 degrees. And then we're just going to go ahead and rearrange here. So this is now going to be 373 minus mg sine 22 degrees. Because we want to isolate for mu k here, right? So that's going to be mu k mg cos 22 degrees, which means that mu k is essentially now 373 minus mg sine 22 degrees divided by mg cos 22 degrees. Now mg we already have. So the mass we were given earlier, it was, I believe, 53 kilograms. Yes, it says 53 kilograms. So we're gonna go ahead and do that. And g is the gravitational constant of 9.8. So here we have everything, and that means that if we plug everything in, we should get the answer. It's going to be 373 minus m, which is 53, times g, 9.8, and then sine 22 degrees, divided by m here, which is, again, 53. G is 9.8. Multiplied by cos of 22 degrees. Now, if you number crunch using a calculator, you would get the final answer of 0.37051. But in this particular case, I'm going to leave it as two significant figures. So it's going to be 0.37. And what I like to do is once I finish the question, I'm going to box it in. Because a lot of teachers like that. When they're marking, they can easily see what the final answer is. And I'm going to do a final statement too, because they seem to also love that as well. So the coefficient, so therefore the coefficient between the crate and the ramp is 0.37. That's it. So if you guys found the video useful, please help out by subscribing and liking the video. Till next time, bye-bye.